In this lesson, I'm going to go over the definition of a one-sided limit, and from there we will develop how you define continuity on a closed interval. If you take a look at this function f, I have it approaching from the left to one value, some abstract value for c, and on the right it's coming from another. Now, to have a one-sided limit, you don't have to have them go to different values, but it may, for the beginning, make a little more sense. What we say is this limit from the left, we write it just like the limit notation, but we put this little negative sign here. And that is the extra symbol that means limit from the left. It has nothing to do with whether this value is negative or positive. It's just since this side is negative infinity, so it's coming from negative infinity. You can look at it that way. So f of x equals L. Notice the function that I've placed here. The limit does not exist, but you can talk about the limit from the left. On the other hand, you can also talk about a limit from the right. And the only difference in the notation is that you put a plus here instead of a minus sign, or a positive instead of a negative. And notice I have a different y value, and I'm saying the limit as x approaches c from the right of f of x equals k. Again, they can be the same, which would mean that the limit will exist, as I'll show you in a moment. But it is very possible to have a one-sided limit on a function whose total limit does not exist. Now, for example, the limit as x approaches 0 of the square root of x does not exist because it goes to 0, 0, but notice to the left of 0 there's nothing, it's undefined, so therefore the limit could not exist there. But you can talk about the limit as x approaches 0 from the right, and that does equal 0. Now, if I put something here and say limit as x approaches 0 with a little negative sign, that would be the limit as x approaches 0 from the left of the square root of x, and that would still not exist. But here you have 0. So what you can do with that is you can actually define the limit that we've already talked about in terms of left and right. Let f be a function and let c and L be real numbers. So we know that the limit as x approaches c of the function f of x equals L if and only if, that's why I have the double f, if and only if, that means it goes back and forth. If the left-hand limit, the limit as x approaches c from the left of this function, is the same as the limit as x approaches c from the right of that function, which are both equal to L. So if these two exist and they both equal L, that means the limit exists, and that limit is L. Now, the reason why one-sided limits are important in terms of continuity is because it allows you to expand on continuity to be on a closed interval. So far it only works on an open interval because no matter what point you choose, there's always going to be a point on both sides as long as it's continuous. You don't have to worry about any endpoints that are defined anyway. But on a closed interval, a and b are endpoints that are defined. So what happens is the following. A function f is continuous on the closed interval a to b if, first of all, it has to be continuous on the open interval, which we've already talked about. And then once you have that, then if you look at a from the right, if that limit is the same as f of a, and then you look at b from the left, if that limit is the same as f of b, where you put it in sort of like direct substitution, then you can go ahead and include those endpoints to change an open interval to a closed interval. Now, honestly, I think it's easier to see when you have a abstract graph here. Say you have f, and let's say it's continuous on the open interval. Well, if you look at a, when I'm saying it's approaching from the right, this is what I mean. Notice it's continuous. It's not continuous on the left. But based on this, as long as this value equals the same as what f of a would be, you're okay here. For the right-hand side, you actually approach from the left. This is the thing that throws the students off the most. is that you've got the left bound approaching from the right and the right bound approaching from the left. But if you think about it, you want it to be continuous inside of the interval. That's why it looks as though it's switched around, but it's really right where it needs to be.